These notes are on isosceles trapezoids. One of the characteristics that we learned is that a trapezoid has exactly one pair of parallel sides. So if I mark right here that parallel and that parallel, these are the pair of parallel sides. Even more specific, an isosceles trapezoid has congruent legs. So the legs are the two sides that connect the sides that are parallel. So here would be one of your legs, and here would be the other leg. One thing to keep in mind, on top of these legs are congruent, is that the two sides that are parallel are not going to be your legs. The other thing about an isosceles trapezoid is that the base angles are congruent. So thinking back to an isosceles triangle, the legs were congruent and the two base angles at the bottom of the triangle were congruent. The same thing works in isosceles trapezoid. If these are the legs right here, this base angle is congruent to this base angle. Up here, this base angle is congruent to this base angle. One thing you don't want to forget is that when we learned about parallelograms, parallelograms had opposite angles that were congruent. A trapezoid is not a parallelogram, so the opposite angles are not congruent. The two on the bottom are congruent, so these two base angles would be congruent, and the two on the top are congruent. So these two would be congruent, and these two would be congruent. One thing that is similar, though, is that these two right here, since these two are parallel lines, these two are connected to the parallel lines, so these are still same side interior angles. So these will still have to add up to equal 180, just like these two over here would have to add up to equal 180. Because there are four sides in a trapezoid, the total degrees still has to add up to equal 360. The last thing in an isosceles trapezoid is that the diagonals are congruent, which means the length from here to here would be congruent to this diagonal, so this length from here to here. So the diagonals are congruent. So even though diagonals are congruent, that does not mean that they bisect. So even though in a parallelogram they did bisect, in an isosceles trapezoid the diagonals are congruent, but they don't necessarily bisect. So if I were to label this trapezoid here A, B, C, D, AC, which is right here, which is the length from here to here, has to be equal to the length from B to D. Those are the characteristics of an isosceles trapezoid. In this first example, it says ABCD is an isosceles trapezoid. So here's my isosceles trapezoid here. Remember, these are parallel right here. And my base angles are congruent. So I'm just going to mark those right here. Base angles are congruent. And these would be congruent as well. You want to be careful because this angle right here and this angle right here are called base angles. And base angles in an isosceles trapezoid, but in a parallelogram, these would add up to 180. since it's an isosceles trapezoid, these are base angles, so they have to equal each other. So you'd have to take your 2x plus 5 and set that equal to your 3x plus 45. So if we set that up, we'd have 2x plus 5. We'd set that equal to our 3x minus 45 is what I meant to say. If I subtract 2x from both sides, you'd get 5 equals x minus 45. Add 45 and you get x equals 50. So x equals 50 is our x value. Notice up here it says to find all 4 angles. So once you get your value for x, you can plug that in. So if x is 50, I go up here and plug that into the 2 times 50 would give you 100, plus 5 would be 105. So this angle would be 105. So angle A would be 105, which means angle B, which is congruent, must also be 105. So that's what you'd write for those. These two right here, angles A and D, still have to be supplementary. So if this is 105, we can take 180 minus 105 to get this angle here, which would be 75. And if we know angle D is 75, angle D and C are base angles, so they have to be congruent, so that makes this angle also 75. So you have to remember that all of these together should give us our total of 360. So that's how we'd solve for that one. The next rule for a trapezoid is there is a segment called a midpoint. So if you look at this diagram, I have A, B, C, D is a trapezoid. AB, right here is segment AB, is parallel to segment CD. So these are parallel, so we can write that in. Those are parallel. This is EF, and EF is called the median. So we can write that over here. It's called the median. And the median is inside of a trapezoid. Some things we know about a median: it's parallel to the bases, so we could also draw that in here. So AB would be considered a base, and DC would be considered a base, so it's also parallel. Its length is the average of the two bases. So if I were to take AB as a base and CD as a base, add those two measurements together and divide by 2 right here, that would give me the length of the median. So we're going to follow this equation to do that. So base plus base divided by 2 is the average of the lengths of the two bases. Its two endpoints are the midpoints of the leg. So this point F here is the midpoint from B to C. So that means that segment BF is congruent to segment FC. Point E is also a midpoint, so that means that segment AE is congruent to segment ED. So if I take a look at this picture here, we have trapezoid ABCD, and I have some lengths here for us to solve practicing that formula. Remember, once you figure out that median, the median is parallel to the two bases, and its endpoints are the middle of the sides that it touches. So for number 1, AB is 5, so we could go ahead and write that up there, 5. So the length of AB would be 5. CD is 17, so we could write that down here. So now we need to find the length of EF, and EF is the median. So you're going to take the average of those two bases, which are 5 and 17. And average means to add them together and then divide by 2, which is what you're going to do. And you should get, once you do that, the length of 11. So we'd have 11, so we could write that right on this line for our length. Now we'll do a separate problem, just using the same picture. In this case, DC is 32, so we can write that in, 32. So that's one of the bases. EF is 28, and notice that's our median, so we would write that there. And we want to find AB. So in this case, we'll just use an X for that. You still set it up the same way, and you still have to add them together, but the two bases in this case, the one is 32 and the other one is X. So to write that out, we would say 32 plus X. And we would still divide that by 2, but we're going to set it equal to 28. So remember, we're trying to solve for X. So in this case, I'm going to multiply both sides by 2. And that's going to cancel these two out. And then we're going to be left with 32 plus X equals 56. And if you subtract your 32 off both sides, you're going to end up with X equals 24. So that's going to be your X value, and 24 would be your length up here in that case. And then you've solved for all of them. The next one, again, we're going to use the same picture, just different measurements. So for this one, we know that EF equals 2x plus 1. So that's our median length. And then we know that AB equals 3x minus 3. And then DC for this one actually equals 8. Once you have your measurements in the right spot, you're going to, again, add up your two bases and set them equal to your median. And make sure you divide your two bases by 2. So to write that out, we're just going to say 3x minus 3 plus 8. And we're going to divide all that by 2. And then we'll set that equal to 2x plus 1. Okay, so once we have that set up, we want to try to solve for this. So to do that, to simplify it down, we're just going to multiply both sides by 2. Now keep in mind, if you're multiplying this side by 2, you're going to be multiplying the whole entire side by 2, like that. That cancels these out. And then we're left with, and we want to simplify this down too, so we'd have 3x, and then negative 3 plus 8 would be plus 5 equals, and then we're just going to distribute this through, so we'd have 4x plus 2. And so in this case, we can subtract our 3x off, and we can subtract our 2, and we're going to be left with 3 equals x, or x equals 3. So we've solved for x. And that's how we'd solve for that one. These are the first two questions of your assignment. So even though they're at the end of your notes, you're going to go ahead and see if you can solve for these. This one says AB equals 4x, DC equals 2x plus 4, and EF equals 20. We're trying to solve for x. And the second part, you're going to use the same diagram still. AB equals x plus 5, DC equals 4, and EF equals 3x plus 3. And again, you're going to solve for your x. So go ahead and see if you can calculate these. You can write your answers right on this sheet, or you can start them on a separate sheet of paper at the beginning of your homework assignment for today. Good luck with these.